Alright guys, so this is the PillBug Lab tutorial. So the first thing you're going to want to do is pull up your lesson plan, which you've probably already done that by now. Just follow the link to the Google Classroom assignment. Here you've got your instructions. Number one, watch how to edit PDFs with Kami Video. So you should have done that already and added Kami to your Chrome browser. So if you look up here, I have Kami right there as an extension in my Chrome browser so that I can use it whenever I need to. Next step is to open the PillBug NoStats PDF right here. So click on that. At the top it says open with, annotate with Kami. So you're going to open it with Kami. This is the teacher view. Student view may look a little bit different, but you should be able to add text boxes, draw, shapes, eraser. That's the main things you're going to be doing here. So the first thing I'm going to do is I'm going to add a text box right here. Type my name in, Matthew. Oops, Matthew. Oops. Kinman. Oops. Oops. Kinman. There you go. All right, there you go. There's my name. Then you go through. So we start off with a question. What is a PillBug? Do PillBugs have a preference for wet or dry environments? That's the question we're trying to solve here. Now keep in mind, you're probably wondering, this is Earth and space science, dude. Why are we worried about PillBugs? Well, they are found on the Earth, but if you remember from the lesson plan or topics, we're talking about the scientific method. So we're just practicing using the scientific method. We don't really care whether PillBugs want wet or dry environments. We're just practicing, just like you practice other things to get better at it. All right, so we have a list of our materials here, and in the other video, the PillBug Lab video that Mr. Austin and I completed, we have all the materials there listed. So then we obtained a PillBug from the stock, we placed the PillBug into a glass beaker for observations. And in the beginning of that video, I got a zoom in using my phone of a PillBug. So from that video, from those observations, click text box, come right here and click 3 times 3 observations that you can make about the PillBug. Observe their natural behavior. So you can type in there like how many legs you think they have, or physical observations of what they look like, or how are they behaving. So remember, you are a scientist, you're researching, so that's kind of what you're looking for. Perform a detailed sketch of a PillBug below. So this one might be a little bit tricky if you have a mouse, or if you have a touch screen, that'd be great. But if you're using the school-issued laptop and you don't have a mouse, you're going to have to use your little mouse thing there on your laptop. So you go over and you click on draw, and you draw what you think a PillBug looks like. And I am an excellent artist. Antennae, legs like crazy. And it's segmented. So anyways, make sure yours looks better than mine. Always strive to make your stuff look better than mine, because you're the one here that matters. All right, so next, test the PillBug's behavior to wet or dry climates. So this is where we do the experiment. To do this, gather choice chamber apparatus. All right, so in the video, I kind of walked through all this stuff already. I cut the filter paper, moistened it, we labeled it. And before you add the PillBugs, create a hypothesis. All right, so that's the first thing we need to do. So type your hypothesis here. Now remember, in the scientific method video that I did, I told you how to do a hypothesis. So I'm not going to explain it to you in this video because I don't want to make this video super long. So go through and form your hypothesis and create a text box. Hypothesis is an educated answer, prediction almost, as to what you think is going to happen. And then we gathered 16 bugs. We dropped 8 in both sides. And then it's going to ask you to calculate the sum of the number of PillBugs on each side. If you remember from basic math, sum is just adding them all together. Then calculate the average. And you may be wondering, This is a science class. Why am I doing math? Well, how do you think any scientist figures out anything? They use math. Statistics, basic math, or not necessarily basic math in a lot of cases, but to figure something out objectively and to obtain empirical evidence is what science is all about. So we have to do math. All right, and then create a bar graph which displays the average number of pill bugs on each side of the choice chamber. So here's your data table. Just disregard standard error of the mean and standard deviation. All we're looking for is amount of pill bugs wet chamber, amount of pill bugs dry chamber. So at 0 minutes to start, we did 8 and 8. So you do a little text box, put it in there, and do 8 and 8. Overall observations. What do you observe? What do you see in the video? We try to do the video as good as possible so that you can see. You can see my watch. I have the timer going, so when it goes down to 9 minutes, that is 1 minute. So then how many do you see on each side? And then at 2 minutes, all the way to 10 minutes. And then the video ends. Find the sum, and then find the average or the mean, and then you have your data. And so remember, disregard standard deviation and standard error of the mean. So the next thing in the scientific method is to analyze data. And what better way to analyze data than to do a graph? So remember, you'll have to do a text box here to label your x-axis and here to label your y-axis. So you'll have to think, what is the independent variable? Independent variable goes on the x-axis. Dependent variable goes on the y-axis. Now I'm going to let you try to figure that out. I'm not going to tell you, and I'm going to see what you put, but think about it. What are we testing? That's what the independent variable is, and that's what goes here on the x. So you label that. And how are we measuring our results? That is your dependent variable. So whatever your dependent variable is, do a text box and label your y-axis. Not a lot of room over here, but try to do it to the best of your ability. Now it says to do a bar graph. So if you click here on shapes, we have rectangles and you have different colors that you could use. We have two different sides. We have wet and dry. So a way that you could do it is at 0 minutes, you could do a green column for wet side and a pink column for dry side. And so then that would be at 0 minutes. And then what about at 1 minute? And so on. Now, if doing it this way takes up too much space, then you're going to need to shorten it. All right? So then your conclusion, the last step of the scientific method, based on your graph, what conclusions can you make about the hypothesis? Remember, give me an educated response based on your data. Nothing short, no one-word answers. I will count off. Remember, this should be a complete sentence. All right, do this to the best of your ability. All right, and that is it.